Now we look at the sign convention. You have to use sign convention. Sign convention in case of spherical mirrors. Sign convention in case of spherical mirrors. See here, if at all I consider a spherical mirror over here, then a incident ray falls on it. Let us suppose there is an object over here. There is an object over here. And here it is the pole. This I call as the pole. And here it is the focus. And here it is the C, center of curvature. Let us say there is an object placed over here and it has got certain height. Let us say this is A, this is B. Then how you can write the ray diagram for this? For that, let us just consider the ray which is going parallel will strike this and comes out of the focus, because parallel beam of light when falls on the spherical surface passes through the focus. So this is the reflected ray. Now whenever I look at the ray which is falling onto the pole, so this is how, if it is incident, from our common knowledge, it will be reflected with the same angle as we have seen. So it is reflected and meeting the ray somewhere here. Similarly, when you look at the ray which is passing through the center of curvature, will be definitely passing like this. That means again it is meeting somewhere here. Therefore, the image is going to be between C and F. So A dash, B dash. This is going to be the image. So AB is the object and A dash, B dash is the image. We will be writing for various positions later, but just for the sake of sign convention, I am just looking into this example. Here AB is along y-axis. So if at all you look at the conditions of coordinate system, this is plus x, this is plus y, this is minus y. Since it is along plus y axis, AB is positive. So height of the object you have to take as positive. Next, height of the image you have to take as negative, because it is onto the negative y-axis. So this is one sign convention you have to follow. The next one is, whenever you are measuring the distances with reference to the pole, you just make a note that pole is to be taken as the reference. So whenever you are measuring the distances with respect to pole, opposite to incident ray, if you are measuring the distances opposite to incident ray, you take as negative, and along the incident ray you take as you have to take as positive. So this is the notation you have to take. So from this example, generally the object is placed over here, and from object to the pole, the distance what we call is u. It is denoted by u. This is the standard notation. So from here to here it is going to be u. Now here u is going to be negative. U is negative because when I am measuring from the pole the distance here, I am measuring from pole to here, whereas ray is coming from here to here. Then again, when I am measuring the distance from pole to the image, let us say this is V. V is called as image distance. That is also going to be negative, because with reference to the incident ray you have to take. Incident ray is coming like this, whereas you are measuring like this. Similarly, focal length. Focal length is nothing but the distance between focus and the pole. This is called as the focal length. So focal length is also going to be negative. So this is how you have to measure. So first in terms of the heights, the second in terms of the distances. So distances with reference to the incident ray. So this is the sign convention you have to adopt. So when you are moving towards the negative x-axis, so with reference to the pole, it is going to be negative x-axis. If the image is formed this side, if you are measuring any distances here, then you have to take it as a positive. So for various positions of the object and images, how the distances are to be measured and how the images are formed, that we are to look at. Now here you look at the magnification. Here magnification is going to be less than 1 because the size of the AB is this much. HO is greater than HI and magnification comes out to be HI by HO, negative. And negative it will become positive. Therefore, you are getting less than 1. So magnification is going to be less than 1. Magnification is defined as the ratio of image distance to the object distance by considering the sign notation. Similarly, image height by object height. There are two formulae. Here you can also define magnification as minus V by U. This is one more method of doing the magnification. So magnification can be image ratio of image height to the object height or image distance to the object distance. So this is how you can calculate. So the conventions are going to be like this. And now how the images are formed for various types of spherical mirrors that we are to look at. So now we are going to look at the image formation due to the convex and concave mirrors.